Hi folks, this is College Algebra, Checkpoint Quiz 8.3. And number 1, we're asked to consider a 2x3 matrix and a 3x4 matrix. And we're just asked what's the dimension or size of the resulting product matrix AB. So if we take a 2x3 matrix and multiply it by a 3x4 matrix, well, first off we have to check to see if this multiplication is even defined. So I look at the number of columns in A. That has to match the number of rows in B. So these two numbers have to check, which they do. Then the dimension of the resulting product matrix is going to be 2 by 4, because for each row of A, and there are 2 of them, it gets multiplied by each column of B, and there are 4 of them. So the product matrix AB is going to be a 2 by 4 matrix. So that'll do it for number 1. And number 2, we're given a 2 by 2 matrix A, and we're asked to find and simplify this matrix polynomial. So a squared minus 7a plus 14i2. So a squared, I'm going to substitute that in. 3, negative 2, 1, 4, minus 7a, so 7 times 3, negative 2, 1, 4. Oops, I forgot the square. Plus 14 times I2. I2 is the 2 by 2 identity matrix. So remember the identity matrices. The 2 tells me it's a 2 by 2. They're always square. And I've got 1s on the diagonal and 0s everywhere else. Alright, so let's start working this out. How do you square a matrix? Well, it's the same thing as when you square a real number. You take the matrix times itself. Now I'm going to subtract from that 7 times this matrix. And how do you take a real number times a matrix? You take that real number times each of the entries. So 7 times 3 is 21. 7 times negative 2 is negative 14. 7 times 1 is 7. And 7 times 4 is 28. Plus 14 times this matrix, and once again, take a real number times a matrix, you take a real number times each of the entries. So that's going to be 14, 0, 0, 14. Okay, so it's down to multiplying this out and then adding and subtracting these matrices together. So we're multiplying a 2 by 2 matrix by a 2 by 2 matrix. This is legal because these numbers match, and the result's going to be a 2 by 2 matrix. And so how do I get that 2 by 2 matrix? Well, for the first entry in the first row, first column, I take the first row of A times the first column of this matrix. So how do you do that? You take 3 times 3, which is 9, negative 2 times 1, which is negative 2, and you add those numbers up to give you 7. To get the entry here, which is the first row, second column, we take the first row of the first matrix times the second column of the second matrix. So I take 3 times negative 2, which is negative 6, 2 times negative 2 times 4, which is negative 8. I add those together and I get negative 14. to get the second row of the product matrix, I'm going to use the second row of the first factor times each of the columns in the second factor. So I take the second row times the first column. I get 1 times 3, which is 3. 4 times 1, which is 4. Add those together, I get 7. I take the second row times the second column. 1 times negative 2 is negative 2. 4 times 4 is 16. Negative 2 plus 16 is a positive 14. Alright, so now we're down to the final step, the subtraction and addition. And how do you subtract and add matrices? You do it entry-wise. So, to get the first row, first column entry, I take 7 minus 21 to give me negative 14 plus 14, that gives me 0. To get the second row, second column, excuse me, first row, second column, I'm going to just take negative 14 minus negative 14, which is 0, plus 0 gives me 0. To get the second row, first column, I take 7 minus 7, which is 0, plus 0, which is 0. Second row, second column, 14 minus 28, negative 14, plus 14 is 0. So, in some sense, we did all that work for nothing, nothing meaning the zero matrix. Actually, this is a demonstration of a deep and magical theorem from a course called linear algebra, which if you're going into mathematics, you'll see soon enough. Let me just shout out the name here. This is an example of the Cayley-Hamilton theorem. So you can drop that name and see what people think about it when you do. That'll do it for section 8.3.